ക്ലാസ് തുടങ്ങുന്നതിന് മുമ്പായി നമ്മുടെ മലയാള കവിതയുടെ ഏറെ പ്രിയങ്കരനായ കവിയായ ശ്രീ അനിൽ പനച്ചൂരൻ നമ്മെ വിട്ടു പിരിഞ്ഞിരിക്കുകയാണ്. മലയാള കവിതയെ ജനകീയമാക്കുന്നതിൽ വലിയ പങ്ക് വഹിച്ച വ്യക്തിയാണ് അദ്ദേഹം. അദ്ദേഹത്തോടുള്ള സ്മരണാർത്ഥമെന്നോണം അദ്ദേഹത്തിൻ്റെ 2 വരി കവിത കേട്ടുകൊണ്ട് ഇന്നത്തെ ക്ലാസ് നമുക്കിവിടെ ആരംഭിക്കാം.
ചോരവീണ മണ്ണിൽ നിന്നുയർന്നു വന്ന പൂമരം ചേതനയിൽ 100 പൂക്കളായി പൊലിക്കവേ, നോക്കുവിൻ സഖാക്കളെ നമ്മൾ വന്ന വീതിയിൽ ആയിരങ്ങൾ ചോര കൊണ്ടെഴുതി വച്ച വാക്കുകൾ. മൂർച്ചയുള്ളൊരായുധങ്ങളല്ല പോരിനാശ്രയം, ചേർച്ചയുള്ള മാനസങ്ങൾ തന്നെയാണതോർക്കണം. ഓർമ്മകൾ മരിച്ചിടാതെ കാക്കണം കരുത്തിനായി, കാരിരുമ്പിലെ തുരുമ്പ് മായ്ക്കണം ജയത്തിനായി. കണ്ണ് നട്ട് നാം വളർത്തിയ വിളകളെ കൊയ്തു കൊണ്ടുപോയ ജന്മികൾ ചരിത്രമായി, സ്വന്ത ജീവിതം ബലി കൊടുത്തു കോടി മനുഷ്യർ പോരടിച്ച് കൊടി പിടിച്ച് നേടിയതീ മോചനം. നമ്മളിപ്പോൾ മറന്നു പോയിരിക്കുന്നത് നമ്മൾ പണ്ടേ സ്വതന്ത്രരാരെന്നൊക്കെ വിചാരിച്ച് നടക്കുന്ന ആൾക്കാരാണ്. അങ്ങനെ കണ്ണ് നട്ട്
Dear students, welcome to another lecture on plastic analysis. So in this lecture, what we are going to do is we are going to continue with our discussions on plastic analysis. So in the previous lecture, what we have learned regarding plastic analysis is we understood the difference between plastic hinge and internal hinge. We understood what is a plastic hinge. We also talked about the concept of shape factor, the need for a plastic analysis. അപ്പോൾ ഈ കാര്യങ്ങളെല്ലാം നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചതാണ്. In this lecture, what we will try to do is we will try to enter into the plastic analysis. So in plastic analysis, there are 2 types of questions that we have to address. First one is we need to find out the collapse load. So collapse load is the load at which the structure or a part of the structure fails. So that is known as the collapse load. Second thing we have to find out is this is required in the designing of a structure. So here what we have to find out is we need to find out the plastic moment capacity. That is required in the design. So we have to find out the plastic moment capacity required. So basically we have 2 types of problems coming. First type is we need to find out the collapse load. Second type of problem is we need to find out the plastic moment capacity required. Okay, these are the 2 types of problems that we have to address. This is so let us try to see how to find this out. Now before we proceed into doing this, we need to understand certain basic concepts to deal with this. Let us try to understand them. So the very first concept that we have to understand is that of collapse load. So first concept is the concept of collapse load. So the collapse load is defined as load factor multiplied by working load. Okay, collapse load is defined as load factor multiplied by the working load. Here what we have to understand is we have to distinguish the for example, we can rewrite this as load factor is equal to the collapse load divided by working load. However, we need to distinguish this from the working stress design. In working stress design, we have factor of safety. So this factor of safety is defined as the yield stress divided by the working or the allowable stress. Okay, so this is the definition for factor of safety. Now this factor of safety we are using in working stress design, and this is the load factor formula. So this we are using in plastic analysis. Okay, so load factor is nothing but collapse load divided by working load. Okay, it is a ratio of collapse load to working load. It is not mentioned in terms of stresses, rather it is mentioned explicitly in terms of loads. Okay, now there are certain theorems using which we can find out the collapse load. So let us try to see what are those theorems using which we find out the collapse load. So the first theorem is known as the static theorem. First theorem is known as the static theorem. It is also known as the lower bound theorem. So first theorem is known as the static theorem or the lower bound theorem. So as per the static theorem, for a given set of for a given structure and loading, so for a given structure and loading, if there exists a safe and statically admissible bending moment distribution, if there exists a safe and statically admissible, so bending moment distribution, then the value of collapse load, then the value of collapse load obtained, that is WC, will always be less than or equal to the actual collapse load. Okay, so whatever collapse load that we are finding out using the static theorem or the lower bound theorem, that will always be less than or equal to the actual collapse load. So the important points that we have to remember is, first thing is the collapse load that we find out using the static theorem or the lower bound theorem will always be less than or equal to the actual collapse load. Second thing is it is for a given structure and loading. Third thing is there has to be a safe and statically admissible bending moment distribution. So that means the bending moment distribution, whatever we are finding, the values of the bending moment has to satisfy the equations of static equilibrium. So if we can find such a bending moment distribution, then the corresponding value that we are going to obtain for the collapse load is going to be always less than or equal to the actual value. So that is the static or the lower bound theorem. Second one is known as the kinetic or the upper bound theorem. So as per the kinetic theorem or the upper bound theorem, again for a given structure and loading, the collapse load corresponding to any assumed collapse mechanism will always be greater than or equal to the actual collapse load. So for a given structure and loading. The collapse load corresponding to any assumed collapse mechanism. So this is the term that is important, the collapse load corresponding to any assumed collapse mechanism. So this will be always greater than or equal to the actual collapse load. So that is the kinetic or the upper bound theorem. And then there is something known as the third one, that is the uniqueness theorem. So what this uniqueness theorem says is, so if we have a statically admissible, safe and statically admissible bending moment distribution, so if for a safe and statically admissible bending moment distribution, sufficient number of plastic hinges are formed so as to form a plastic mechanism, then the WC found will be equal to the WC actual. So here what we have done is we have combined the static theorem as well as the kinetic theorem. That is, for a given statically admissible bending moment distribution, if for this sufficient number of plastic hinges are formed to form a plastic mechanism, then the collapse load will be equal to the actual collapse load. This is known as the uniqueness theorem. So most of the time what we are going to make use of is, we are going to make use of the uh, uniqueness theorem, and we are trying to find out the actual uh, or a unique value of the plastic moment capacity. So the rest of the uh, lecture will be related to how to find out the plastic moment capacity. Now next thing is, let us find out what are the possible locations of plastic hinges. So what are the possible locations of plastic hinges in a structure? So first one is, it can be a point of maximum moment. So it can be a point of maximum moment. So what are the points of maximum moment? One point can be interior support. Second one is, it can be uh, under concentrated loads. Third one is, explicitly it can be a point of maximum moment. So these are the different points. Second one is where there is a sudden change in cross section. So when there is a sudden change in the cross section, there also we can have possibility of formation of plastic hinges. Now another thing is, we want to know what is the number of plastic hinges that are required to form a mechanism. So next one is the number of plastic hinges required to form a mechanism. So we can represent this as NP, and this is nothing but the degree of static indeterminacy plus 1. So the number of plastic hinges that are required to form a mechanism is the degree of static indeterminacy plus 1. And another quantity we need to understand is the number of possible mechanisms. So the number of possible mechanisms is equal to number of possible plastic hinges, that is n, minus the degree of static indeterminacy, that is ns. Okay, so the number of two things are there. First one is number of possible plastic hinges, that is n. Second one is number of plastic hinges required to form a mechanism, that is ns plus 1. And third one is the number of possible mechanisms, that is number of possible plastic hinges minus ns. So these are the three things that we need to keep in mind. And in here what we are going to do is we are trying to apply the kinetic method, and here what we will be doing is we will be equating the internal work done by the plastic hinges to the external work done by the loads. So this internal work done we will be equating to the external virtual work done. We are going to use the principle of virtual work to solve this problems and find out the plastic moment capacity as well as the collapse loads. So let us take